Okay, so today we're just kind of reviewing 6.3, essential limit theorem. I'm also going to go over 6.4, the normal approximation to the binomial, and then we're going to review for the exam, which is in 2 days. You have Connect Math 6.3 due today. Do not forget, for the z-scores, you can only use 2 decimal places. If you use more than 2 decimal places, you're going to get a wrong answer, and you're not going to know why, right? Because the program believes you're using a table which only has 2 decimal places. And you're only going to use 4 for your area, so make sure you do that when you do these problems. And then Project Lab 5, that will be due the class after the exam. So that'll be due on your exams on Thursday, it'll be due on Tuesday. And I'm going to most likely not have class if you guys are good. Is the Thursday before spring break probably the best day to not have class? Is that the best one?
Yeah.
Okay, so we'll do that. So this Thursday we have exam, and then we'll have class on the following Tuesday, and then no class after that. The exam is going to be in 2 days. Covers chapters 3, 5, and 6. I will have a review session tomorrow night in 6:01 from 6:30 to 8. And please email me if I'm late. Should be. Okay, and then there are some exam guidelines. So the first part is that you need a basic calculator. So very, very simple calculator. Even this one is probably too complicated, right? It should be even more basic than that. And then, so you'll do that part, you'll turn it in, you'll pick up another part that's the same color. So whatever color yours is, if yours is blue, you pick up a blue one. If yours is pink, you pick up a pink one. If yours is orange, you pick up an orange one. Do you guys understand what I'm saying? Your A and B should be the same color. So when you put down one color, you should grab the part 2 of the same color. Again, you get 1/2 page of notes, one-sided, and then you also need to write down. I'm going to show you some of the things you can do for some of these formulas, but you need to write down the formula with numbers in them, not just the general formula, but the actual formula with 10 choose 3 times 0.4 to the whatever times 0.6 to the whatever. Also, make sure you bring your binder with your in-class quizzes done and corrected in one section. So quizzes in one section, everything else in the other section. Even if you mix them normally, because it's faster for me to just be able to go through them. I have to look at everybody's during the course of the exam. Ideally, while people are still working, before people start finishing up for part 1, which is really hard. So I really need you guys to have those organized. One section for quizzes, one section for everything else, for the in-class notes and labs that we do. And then obviously your other extra stuff you should bring with you as well, if you have done any smart shops or things like that. Here's an important concept. Michael, go ahead and read this for us.
Important concept. What is the range of values that z-scores can be? And what is the range of values that the area under the curve can be?
So I want you guys to take just 30 seconds with your neighbors and discuss what you think those 2 ranges are. Go ahead.
That one is your news and your standard. The z-scores. Oh, because this is the range, right? Yes. Yes, I think you're right. Yeah. Because it's saying range.
Okay, so first of all, z-scores, where do you find those? On the inside or along here along the bottom? Along the bottom. So they could be here, or they could be there, they could be way out here. What are the range of values that z-scores can be?
Infinity.
Yeah, negative infinity, it can be negative infinity to positive infinity. Everybody with me on that part? Areas are inside of here. This is your area under the curve. It's this space in here. What's the range of values that an area can be? Yeah, you get an area anywhere from 0 to 1. Does everybody understand that? In other words, it's a probability from 0% to 100%. Right, anywhere in there. Good? Does everybody understand that? 100%, not 100, because 100 is a lot different than 100%. If you think that they're the same, then you give me 100 cents and I'll give you. No, wait. I'll give you 100 cents. You give me $100. We'll do that over and over again, like all day long. It's totally fine with me. Okay. All right. The other things that we kind of have gone from is sometimes I will ask you. This is one of the ones we went over last class. Is the standard thing is I give you an x value, and we'll know the area that's above or below it. So the first thing is you take that x value, you can convert it to a z-score, and then you feed it into normal CDF to get your area to the left or the right. Those are the two steps. Everybody good with that part? So here's quiz number 1. Does anybody need just another 30 seconds to finish up these?
Yes, please.
Okay. So first, convert it to a z-score. And draw your picture. So what are the things, so remember, for any normal distribution, you care about the mean and the standard deviation. I have to give you those. Do you guys know the mean and standard deviation of this?
Yes.
Yep. What's the mean? 105. What's the standard deviation? 20. Great. So what do I want to find the z-score of? 133. How do you find it? See how far it is from the mean? Right. So average is where you are, you put that in, right? Oh, yeah. Yeah, but yeah, perfect. Give you a better equal than that, though. Yeah. Okay. You want to pop it up to? Oh, that's fine. Yes, I think you're going to put it in here.
Oh, I
What's the z-score?
It seems like you're going that way.
The z-score is 25. So it's bigger than 0, right?
Okay, guys, listen up. Vanessa's going to explain what she did for the first one. Vanessa, go ahead.
So I took the 133, which is the value that we're trying to find the z-score for, minus the mean of 105, divided by the standard deviation gives you 1.4. So that's the z-score. Looking for less than 133.
So see how she marked it in here, and then she shaded because it's, sorry, why'd you shade to the left?
Because we're looking for less than 133. So whatever's lower than 1.4. So then I found a normal CDF of negative 99 and 1.4,
Great.
giving me 0.9192.
Perfect. And then I like how she labeled it. She put it up there as well. And I think I'm okay with you if you do NMCDF. I think I'm going to be okay with that.
Oh, you usually have L, right?
I'm sorry? Yeah, that's okay. I'm good with that. That seems good. All right. So more than 112. Again, you need to find the z-score, right? Is everybody done with this part? Yes? Yes. I mean, you need another 30 seconds to do the second part B? That was a yes? No? Let's do the front page. Okay, so people are done. So here, more than 112, I need to find the z-score for 112. So z equals, for 112 is going to be 112 minus my mean. What's my mean? 105 divided by my standard deviation 20. And what did you guys get for that? 0.35? Perfect. Okay, when you draw a picture, and you will need to draw a picture, these are the steps I need you to do. Give me your hill and your ground and a little tiny mark where the middle is. Just a small mark. Then, where's 0.35? It's somewhere on the right. 0.35, up, and then do I want to shade to the right or the left of this? More than, to the right. And then I need the area, so it's going to be normal CDF. If I kind of go way out, this would be infinity, I don't know, 80, 84, any large number, doesn't matter. 0.33, comma, 84. And what did you guys get for this? 3632. So this is 0.3632 inside of there. Okay. Good. Did you guys all check your answers? Rob, did you guys check your answers?
Yes.
The other thing you might be asked to do is, if I give you an area, find the x value that goes with it. So the first thing is figure out what the left area is, what the area is on the left. And maybe we give it to you automatically and you just have to say, oh, the area on the left is this. Or if we give you the area on the right, you might have to subtract to find the area on the left. Right? If this is 70%, then you know this must be 30%, because the whole thing has to add up to 1 or 100%. Then, use inverse norm to find the z-score that goes with that area, that left area. And then the last thing is convert that z-score to an x value. So, and you have some homework problems on that, I think. Here's your quiz number 2 on a uniform distribution. Our probability is the same thing as what? Area under the curve and probability, area under the curve, and percent of the population. Perfect. Thanks, Courtney. So in order to find the probability, we just need to find the area. Uniform is super easy because it's just a rectangle. Right? 0 probability here, and then whatever that's all the same probability there, and then 0 probability there. How do you find the area of a rectangle? Length times width, or in this case it'd be length times height. So we know the whole area is, how long is the whole area? What's my length of this rectangle? I'm sorry, of the rectangle? 8. So what's the height of my rectangle have to be? 1 over 8, the reciprocal. Because remember, this length times my height has to add up to 1 for the whole rectangle. Right? That's for the whole rectangle. So that tells me what my height is of this rectangle. So my height is 1/8. So that way I know that this is 1/8. So no matter what, if I grab any little piece anywhere along here, the height will be 1/8. So everybody said the height doesn't change. Now that I know what the height is, I know the height of anywhere along here is 1/8. What's the probability that it's between 4 and 6 minutes? So 4 minutes, 6 minutes. I don't know, maybe this is 4. This is not to scale. Maybe this is 6. So I need to find the area of this rectangle here. What's the height? 1/8. We found that a second ago. So I know this is 1/8. And what's the length of it from 4 to 6? 2. Good. Because remember, it's continuous. So it's just from 4 to 6. It's exactly 4 minutes to exactly 6 minutes. 2 minutes. Okay, great. So then my area, or my probability, will be 2 times 1/8, which is 2/8, or 25%. You can write any one of those, it doesn't matter. You can write 2/8, you can write 25%, you can write 1/4, I don't care. Any one of those is fine. Good? Okay. Do you guys need 30 seconds to check with your neighbors about this part? Yes? Okay, take a minute, take 30 seconds.
Yeah, now, yeah.
I don't understand.
And if you both understand, then just one of you explain to the other one, just so you get practice explaining it.
But why 2? Yeah, so you go by 2. So this is 2 minutes, 2 minutes. Why 1/8?
Adam, explain this to us.
So why 1/8?
It'll help the audience.
Every 8 minutes.
Explain to them.
So what's like us? Every 8 minutes. You get it? So, because you have 2 minutes, that's what you have. So that's these are the 2 minutes. 2, 4, 6, 8, 10. Right? No 1/8.
Remember, the process of explaining forces you to think about it and create a clear mental structure.
A of us.
So that clear mental structure is what helps you recall it easier from long-term memory.
And then, but you always have a 2 minute line, so 0, 2 minutes. So it starts at 2. So every 2 minutes, so it increases by 2.
Okay, let's move on.
You get it? Yeah. Yeah.
Okay, so then the other thing we talked about last class was central limit theorem. So remember, this is when I take, it's like the mean of the means. You guys remember? I'm taking a sample and the mean of that sample. So every one of these represents the average of 30. This is one sample, average of those 30. This is another sample. This is another average of 30. Another sample. Another average of 30. This is another sample. So here I've taken 12 different samples. Right? Take a sample, find their average. Take another sample, find their average. I do that over and over again. The central limit theorem says that these sample means will be normally distributed, regardless of whether they come from a normal distribution or not, because they're averages. So the averages will all be centered around what you think the average should be, and most likely there, and then most of them there, and then fewer and fewer as you go further out. It makes this nice normal curve. So so that's kind of this neat thing. That's what we talked about last class. Let's get someone talking about this. Megan, go ahead and read.
The sampling distribution of the sample mean is the distribution of all possible sample means with all samples having the same sample size n taken from the same population.
Keep going, yeah.
Example, we have the numbers 1 through 40. If I were to take every sample of 30 of those and found their means, it would form a normal distribution.
Right. So if I had the numbers 1 through 40, I took every possible sample from there of 30, right? And took the average of each one of those samples, it would form a really nice normal distribution. That's really hard to show, a sample of 30, out of 40 numbers in every possible combination. So I'm just going to show you just the beginning of it. So this is a uniform distribution, right? 1 through 6. Everyone's equal likely. What's probability I pick a 2? What's probability I randomly pick 2?
1 out of 6.
1 out of 6. And what's probability I randomly pick 5?
1 out of 6.
So each one of these is equally likely, right? So if I took every possible combination, I'm just going to take 2 of them and average it. I'm going to take another 2 of them and average it. Every possible combination of grabbing 2 of them and averaging them. This is what I get. All right, I take 1 and 2, average them, 1.5. 1 and 3, average those, 2. 1 and 4, average those, 2.5. 1 and 5, average them, 3. 1 and 6, if I average those 2, I get 3.5. Everybody kind of follow what I'm doing? If I take 2 and 3 and average them, I'll get 2.5. 2 and 4, average them, I'll get 3. Grab 2 and 6 and average them. 2 and 5, and then 2 and 6. So I took every possible combination of, so like here, if I then took 3 and 4 and average them, I'd get 3.5. If I took 3 and 6 and average them, I'd get 4. If I took 3 and 6, if I took this is every possible combination of 2 of them. Everybody on board with what happened? I've taken every way of grabbing 2 of those numbers, and I average those 2 numbers. So this is 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 3, 2 and 4, 2 and 5, 2 and 6, 3 and 4, 3 and 5, 3 and 6, 4 and 5, 4 and 6, and 5 and 6. So that's every possible way of grabbing 2 of them. Then it forms, and I average each one of those means in my sample of 2, and will form this. Right, I have 1 of each of these, I have 2 of each of those, I have 3 of these, 2 of those, 2 of those, 1 of those, and 1 of those. Right, the most likely thing I get is 3.5. Right, because that's the average of if you randomly took 1 and 6, or you randomly took 2 and 5, or you randomly took 3 and 4. Those all average to 3.5. Are you guys with me on this part? Yeah. Okay, no worries. So you can see, even that, this is starting to look kind of normal, right? Just the beginnings of normal. And if you take a sample of 30, then then it becomes, that's kind of your then it starts looking like a nice normal curve. Also, we talked about, well, let me get someone else to say this. Noe, go ahead.
Remember Steph Curry's 2016, if he averages 30 points a game that borders on unusual is about 50 points. If we randomly sample 25 games, the average of those 25 games will never be 50 points.
Right? I could pick one game of his randomly, and I might get a 50-point game. You might say, okay, that could happen. Right? But I'm not going to take an average of 25 of his games and say, oh yeah, the average of 25 of his games is 50 points. That's not possible. Right? Because when you grab a game and you grab another game, and you grab a bunch of games, then you're going to get some small ones in there along with some big ones. So they're going to kind of cancel each other out, and you're going to get something kind of right around the middle in here. So you'll notice it's a smaller standard deviation. Right? See how this one's not varying very much, whereas the red one, if you're looking at just one game, the red part is just one game. You could be anywhere along this area here. Most of them are around here, but as you get further out, you can get some over here or over here. It's pretty spread out. Right? You could have a 10-point game, you can have a 50-point game, but if you're averaging 25 of them, it's going to be right in this range, which means that the standard deviation, the center is still the same. You guys remember that? We talked about how the mean and standard deviation are the two things you need to know about a normal distribution. One is the mean, where it's centered. They're both centered at the same spot, but the standard deviation, the shape is different. One game, it's a really wide spread out shape, and average of 25 games is this really tight, tiny curve here, because it's all going to be right in this range. How much smaller is the standard deviation? It's sigma. I'll use this sigma here. This sigma, we call it sigma x bar. It's equal to the original sigma divided by the square root of n. Right, so the more you take, the smaller and smaller that becomes, because the more likely it is to. Here's the thing. If I took an average of all of his games, How many games do they play this season? Anybody know? 82. Great. If my n was 82, and I took a sample of 82 of all of them, it would be centered right here, and it would have a variance of nothing. Because I take a sample of 82, and that's all the games. It can only be there. Do you guys understand what I'm saying? It wouldn't vary at all. So that's kind of how that works. If you take a big enough sample, the variance becomes really small. Because you're always going to get really close to that mean, the more bigger and bigger your sample is. Okay. So there are some conclusions. Jackie, go ahead and read for us.
Distribution of the sample mu
X
will,
bar. X bar.
the X bar will, as the sample size increases, approach a normal distribution. 2, the mean of the sample means that is a population mean mu. The standard deviation of all sample means is standard deviation and square.
Over square root of n. So mu x bar, mu of the sample means, is equal to just your regular mean. That doesn't change. You're still centered where you expect it to be. But your standard deviation of your sample means, sigma x bar, is equal to your normal sigma divided by square root of n. Those are the two things you need. You really only need this, because the other one's exactly the same. So problem 3 from the quiz, find these things. Right, so our mean is just our mean for the standard deviation, our mean for the sample mean is just our regular mean, which is 36. Did everybody find the other one? Okay, good. So then our sigma x bar is equal to sigma over square root of n. So that's 7 over square root of 42, and you guys got what?
1.08.
1.08. Good. If you use 1.1, I'd be okay with that also. I don't care. Either one's fine. Actually, you know what? Go more is better, because we're going to be using this for other things. So yeah, give me a couple. So this is just to point out that see how this is a normal distribution up there? That's for n is 1. That's just how it regularly is. If you just pick one person, the probability is in each spot. Here, if you take a sample of 10 and you average, and look at the average of a sample of 10, then it starts looking kind of more clumped up, right? The standard deviation starts getting smaller. If I take an average of 50 of them and just use their average, sample of 50, the average of that, over and over, another sample of 50, the average of that, over and over again, then it's going to end up being really tight in here. Each one of these dots represents a sample of 50. The neat thing about central limit theorem is that it even applies to things that are not normally distributed. So remember, this is the uniform distribution that we talked about before, where 1, 2, 3, 4, 5, and 6 are all equally likely. If I take a sample of 10 items and average of them, sample 10 of them, average them, sample 10 of them again, average them over and over again, then I'm going to get, it starts looking a little bit normal, but not necessarily just yet. But if I get a sample of 50, then it's totally got that more of that normal distribution. This is not quite enough to be able to be sure it's a normal distribution thing. When you get to 30 or more, then you're definitely in a normal distribution range. And it can even be U-shaped, almost like the opposite of a normal distribution. And if you have an n of 10, it starts looking kind of normal, and then n of 50, then it's totally in that normal distribution chain. All right, there are a couple conditions for using it. Other Vanessa F, go ahead and read.
Conditions for using the central limit theorem. If the original variable is not normal, a sample size of 30 or more is needed. If the original variable is normally distributed, then any sample size n will work.
Great. And this is your quiz problem. Remember, we need to find some things. So we need to figure out every problem is going to have a mean and a standard deviation. You need to find those two things. So what are those? Let's get someone reading this one. Jacob, go ahead and read the problem for us.
A survey found that the American family generates an average of 17.2 pounds of glass garbage. Assume the standard deviation of the distribution is 2.5. Find the probability that the mean of a sample of 55 families will be between 17 and 18.
Great. So what's my mean and what's my standard deviation of the problem? Everybody?
So mean is 17.2.
Mean, yeah, average of 17.2. So that's fixed before I even ask a question. And then what's the other thing?
The standard deviation is 2.5.
Yeah. Standard deviation is 2.5. Now, what are they asking us for? They're asking us to do this. Do you guys see where that part comes in? That's a little different. That's what they're asking us to do. Are they asking you to find the probability that what? Find the probability that I randomly pick one family? Or is this going to be an average of a bunch of families? Average of a bunch of families. So as soon as you're talking about find the probability that the mean of a sample of 55, now we have an n, sample of 55, mean of a sample of 55, this is my n, then this is going to be a central limit theorem problem, and you need to use sigma x bar to find your z-score instead of sigma. Everything else is going to be the same. So first, you need to find sigma x bar, and then you need to find your z-score. And then it goes to, just like we did in the previous problem, a couple problems ago. Find your z-score for what? Sample of 55. So sample of 55 means that I'm sampling 55 families. That's my n. Sample of, that's your n, will be between, so what are kind of my x's here? 17 and 18. So those are in this case, my x bars, because they're sample means. So you need to find the z-scores for those, and I'll give you guys a couple minutes to sort that out if you haven't.